In the Solve It, you looked for a way to use two reflections to produce the same image as a given horizontal translation. In this lesson, you will learn that any rigid motion can be expressed as a composition of reflections. The term isometry means same distance. An isometry is a transformation that preserves distance or length. So translations, reflections, and rotations are isometries. Expressing isometries as compositions of reflections depends on the following theorem. Theorem 9.1. The composition of two or more isometries is an isometry. In Lesson 9.1, you learned that a composition of transformations is a combination of two or more transformations, one performed after the other. Any translation or rotation can be expressed as the composition of two reflections. Theorem 9.2, reflections across parallel lines. A composition of reflections across two parallel lines is a translation. Notice the diagram at the right, the lines of reflection and the triangle and its image, and second image. You can write the composition as R sub m of R sub L of triangle ABC equals triangle A double prime, B double prime, C double prime. Or R sub m of R sub L of triangle ABC equals triangle A double prime, B double prime, C double prime. Segment AA prime, segment BB prime, and segment CC prime are all perpendicular to lines L and M. Take note in the diagram, triangle ABC and triangle A double prime, B double prime, C double prime have the same orientation. Problem 1. Composing reflections across parallel lines. What is R sub m of R sub L of J? What is the distance of the resulting translation? Well, note the diagram. We have a bold J and two lines of reflection, line L and line M, which are parallel. As you do the two reflections, keep track of the distance moved by a point P of the preimage. Step 1. We'll reflect J across line L. Now notice in our notation, R sub L is second in the list. See, we have R sub m of R sub L of J. But we're going to perform R sub L first. So reflecting J across L, PA, the distance, equals AP prime. So PP prime equals 2AP prime. Step 2, reflect the image across M. P prime B equals BP double prime. So P prime P double prime equals 2 times P prime B. Note that P moved a total distance of 2 times the distance AP prime plus 2 times P prime B, which we can also state as 2 times AB. The red arrow shows the translation. The total distance P moved is 2 times AB. Because line AB is perpendicular to line L, AB is the distance between L and M. The distance of the translation is twice the distance between L and M. Your turn. Part A. Draw parallel lines L and M as in problem 1. Draw J between L and M. What is the image of R sub m of R sub L of J? What is the distance of the resulting translation? And part B, a reasoning item. Use the results of part A in problem 1. Make a conjecture about the distance of any translation that is the result of a composition of reflections across two parallel lines.